Yo. Alright, quick vector review, basic vector review. Let me make sure it's rolling. Yeah. Alright. We got two vectors here. Notice the notation. We're using the brackets for the vectors. These are components. Components. That's a horizontal component. That's a vertical component. They are not coordinates. They are components of vectors. Alright? So this notation here means the magnitude of v. So when you find a magnitude, we're always using the Pythagorean theorem. Alright, and let's see, 36 plus 4 square root of 40. That is sufficient. If you want to reduce this down, you'll find that it's 2 square root of 10. Alright? That's all it is. That's all it is. That's the length. That's the length of this vector. It sounds really simple. It is. Okay? If I want to add or combine, this is called a linear combination of vectors. Combining vectors. I'm going to go negative 2 times v and then subtract u. So I'm going to write that out. v minus u. Alright, so negative 2 times v is a positive 12 and a positive 4. And now I'm just going to subtract the components. So 12 minus negative 4 is 12 plus 4. That's 16. 4 minus negative 5 is positive 9. Done. Alright? Done. Okay, now the direction of v. I'm going to show you what we do, and if you want to remember what you do and just memorize that, that's cool. Alright? Direction of v. Okay? It's negative. So if I were to sketch it in standard position, if the vector were to start there with its initial point and go left 6 and down 2, it's going to go left 6, down 2. There's the vector. Alright? And what I want to know is I want to know that angle. That's going to be our angle. Okay? We're always going to use tangent. We're always going to use tangent. So the angle, or I should say, yeah, let's just do it. Because we're finding an angle, we're going to use the inverse tangent of the y-coordinate divided by the x-coordinate, and it's always that way. Why do we do that? If I make this a right triangle, this is negative 2 and this is 6, and if this is my reference angle, tangent is opposite over adjacent. So it's the y-coordinate over the x-coordinate. So opposite over adjacent. And it's always going to be y over x. Okay? Now, oh, where's my calculator? I wanted to make sure I was in degree mode there. And it gives me 18.4. Alright? So I found this blue angle that I shaded in, but I want the entire angle counterclockwise from the positive x-axis. So when it's in the quadrant 3, I'm going to add 180 degrees to it. And there's my direction. So that angle tells me the direction of the vector. Now, just a reminder, when it's quadrant 3 or quadrant 2, you're going to add 180 degrees to it. When it's quadrant 4, you're going to add 360. When it's quadrant 1, you don't have to add anything at all. Alright, last thing is the direction between the two vectors. And I would like you to use this formula. And before I use this formula, I'm going to tell you that your first option is just to find the direction of both of them individually, and then find the difference between those two vectors, between those two angles, which is pretty easy, and you can use that. I'm going to use this formula here because it's going to allow me to talk about dot product. Okay? So it's cosine of theta is equal to the dot product divided by the two magnitudes. Okay? So the dot product between u and v is first times the first plus second times the second. And I'm going to divide by their magnitudes. We already found the magnitude of v, which is square root of 40. And the magnitude of u is going to be, let's do that real quick. That's 16 plus 25 is 41, I believe. Yep. And there's our formula. Okay. So 24 minus 10 is 14, divided by these guys. And I'm just going to take, the inverse cosine of that. Okay. Make sure the entire denominator is in parentheses. I got 69.8 degrees. That's the angle in between the vectors. This will always be less than 180.